Engineering Dynamics Session 14, Kinetics of a Particle. We just start, we are moving from kinematics to kinetics of a particle. So first, let's see what kinetic is. So let's see what kinetics is. Kinetics is from the Greek word like kinesis, which means pertaining to movement. And it's the study of motion and its causes. So it just related the motion with the forces and velocity and acceleration. So kinetics is the study of relation between forces and acceleration and their causes. So for example, in kinematics, we didn't have any a force involved, but we study the acceleration and velocity in kinematics as well, but in kinetics, it's forces and the causes of them. So this relation is based on Newton's second law, and summation of forces is m times acceleration, mass in acceleration. So if you just consider a ball moving from right to left, it's just the forces F1, F2, and resultant forces. So this is a moving ball is a kinetic diagrams, and the other one is free body diagram. This is from statics. If we just have a 10 kilogram projectile, in this example, like 10 kg projectile is fired from upward vertically from the ground, like with the height of z. It just shooted to the height of z from the ground. The initial velocity of 50 meter per seconds. We want to determine the maximum height, what the maximum elevation of z is. In case 1, which there is no resistance of air, and in the second part, which is there is a drag force decelerating the ball by this equation, where v is the speed of the meter per second. Let's see how we can approach our problem. In this problem, we have a first part is our free body diagram and equation of motion, and like our kinematics, which just says at z equal to 0, v naught is 50 meter per second. So from kinematics or physics, v squared minus v naught squared is 2 times acceleration times z minus z naught, and v at the very top ball will stop and bounce back. That's 0 velocity minus initial velocity, which is 15 squared over here, and that's times 2 equal to 2 times a negative 9.81 downward acceleration, and 19.8 is just 9.8 times 10, which is the mass, times h minus 0, and h, it just gives us an h is equal to 127 meters, maximum height which ball can travel without air resistance. Now let's see what if we have a drag force or air resistance. Resistance is the same like drag force, which is provided with this equation. So our drag force is equal to, it is just provided in the problem statement with this equation, and equation of motion is summation of forces in z direction equal to m times az. So this is our drag force minus mg, mass times 10 kg times 9.81, which is the acceleration in SI unit, and g in SI unit is equal to m times az, which is 10 times a. If you solve it, it just gives you a acceleration of a negative 0.001 v squared plus 981. If you take a closer look to the problem, it just, you can easily see acceleration is not constant because ft is a function of velocity. So acceleration is likewise a function of our velocity. So we can write down this equation. A, just consider this one like positive. A times dz is equal to v, and we already calculate our v equation. A equation or acceleration equation is equal to times d. And if you just integrate it from 0 to height of z, and from the initial velocity to the final velocity, which is the stopping point, and vd, just rearrange the equation like this and solve this integration, it just gives you this equation. And it just gives you, and if you solve the integration, it just gives you a z is equal to maximum height is equal to 114 meters. And the answer for the second part, for part B, is less than part A, and that's due to air resistance dragging down the ball a higher pace. So it just prevent it to go to the maximum height like part A, which is 127 meters in part A without air resistance. This is without drag force, and 114 meters is the maximum height with considering the drag force. Thank you. We just start the kinetics of particle, the motion of particle containing the forces and their effects, and we'll solve more problem on kinetics of a particle with different method. Thank you.